In this video, we are going to look at elasticity. So elasticity is the percentage change in quantity divided by the percentage change in price. So percentage change in quantity divided by the percentage change in price. Okay. If it is elasticity of demand, then it is percentage change in quantity demanded divided by the percentage change in price. If it is elasticity of supply, then percentage change in quantity supplied divided by percentage change in price. One remark: if two linear demand or supply curves, okay, let me write, if two linear demand or supply curves run through a common point, then at any given quantity, the curve that is flatter is more elastic. The curve that is flatter is more elastic. Let me show you from the graph. In the vertical we write price, and horizontal we write quantity. Let me draw the supply curve. Okay, so this is our common point. Let's say the price at this point is $40 and the quantity is 75. Now let's increase the price. Let's say the price at this point is $50 and quantity is 80 unit, but at the same price the quantity given by this curve is much larger. Let's say this is 90. So you can see that this curve is less steep, or we can say small slope, whereas this curve is more steep or large slope. Okay, so the flatter the curve, the elasticity is higher. So here you can see that the less steep curve has more elasticity. Okay, so this is more elastic because the change in quantity supplied, because these are the supply curves, so change in quantity supplied is much higher when the curve is less steep. Okay, or the straight line in this case is less steep, so this is more elastic. All right, now let's look at the determinants of elasticity of demand. Determinants of the elasticity of demand. So first determinant is availability of substitutes. Okay, and this is more fundamental determinant. Fundamental determinant. Why I'm saying so? Because all other determinants are derived, or or you can say based on this determinant, availability of substitutes, they are somewhere related to this determinant. Okay, so let's look at this. So whenever we have fewer substitutes, it becomes harder to change the quantity. Okay, so fewer substitutes makes it harder for consumers to adjust quantity. Okay, when price changes. When price changes. So fewer substitute makes it harder, then the demand is inelastic. Okay, demand is inelastic. All right, so for example, what is the substitute for food? I mean, you could say drink could be substitute for food, but this is not so much logical, I would say. So there are not many substitute for food, right? So in this case, the demand is inelastic. But what about the substitute for lettuce? Almost all green vegetables are the substitute for lettuce, right? So in that case, demand is elastic. So many substitutes means demand in elastic. All right. Now let's look at the second determinant, time horizon. So less time we have means lower elasticity. So less time to adjust means lower elasticity. For example, um, suppose let's say you are choosing some courses for your next semester, and the professor gives you only 30 minutes to choose the courses, or let's say there are many professors teaching the same course, and you are trying to decide which subclass you should take, and the professor only gives you 30 minutes to decide. So you are under time constraint, right? You have time pressure. So in that case, you do not have much things to do. You will choose just one class, right? Because there is a risk that if you do not get enrolled in another class and you do not choose the first class, then your schedule will be ruined for the whole semester. Okay, so you have less time means the demand is inelastic, okay, or less elastic. So less time means lower elasticity. Now third determinant is classification of good. Classification of the good. Okay, so the less specific the classification, and this is related to the first determinant, that is availability of substitutes. So it is same as like you basically classify things, like I give the example of lettuce. So uh, lettuce is basically a vegetable, right? So you do not have much more substitute for vegetable. If I say what are the substitute for vegetables, So you do not have much substitutes, right? But if I say what are the substitute for lettuce, then you have so many substitutes. Almost all green vegetable are the substitutes. So this is related to the first determinant. Okay, so I'm not gonna explain so much about this determinant. So our fourth determinant is nature of good. Okay, so in this determinant I'm talking about two types of good. First is necessities or necessary goods. Okay, and second is luxurious goods or luxuries. Okay, so for necessary goods we do not have much, you know, options. Like for say cooking salt. Okay, we do not have much option for the cooking salt. And also for the necessary goods we do not think a lot. Okay, we just uh, purchase that. We do not think about that too much. So for necessary goods, the change in quantity demanded or supplied is not that high when price changes. Okay, so in case of necessary goods, the demand is relatively less elastic. Okay, whereas when it comes to luxurious goods, um, it is more sensitive to price changes. Okay, so we can live without luxurious goods as well, right? But we cannot live without necessary goods. So for luxurious goods, demand is or supply is relatively more elastic. Okay, so this is less elastic, this is more elastic. All right, now fifth factor is size of the purchase. Okay, so in the previous example, in the previous determinant I gave the example of cooking salt. So my question is, how much do you spend on cooking salt of your salary? Very little, right? And whenever we spend a very small amount of our money in something, we do not really care about that. Okay, so we are less sensitive to price changes when the good feels cheap. Okay, so for cheaper goods, demand is less elastic. Okay, less elastic. And again, for expensive goods, where the where we spend a large amount of our salary or budget, so this is more sensitive to price changes. We are more sensitive to price changes when the good feels expensive. So the demand is more elastic. We cut down our expenditure in that case. So more elastic. So these are the determinants. All right. Now, now let's look at some mathematical definitions. So mathematically, we define elasticity as percentage change in quantity divided by percentage change in price. Okay, so this is a very basic formula of elasticity. Let's look at a very trivial example of this. Let's say price of oil increases by 10% and over a period of several years the quantity demanded falls by 5%. So the question is, what is the price elasticity of demand for oil? price elasticity of demand for oil. Okay, here I have used the term price, so please do not get confused, because sometimes the price is omitted and we simply ask elasticity of demand. Okay, so this is basically same. So here we use the fundamental definition. So elasticity is change in quantity demanded, that is percentage change in quantity demanded. So minus 5%. Here we put the negative sign to show the direction of change. Okay, so please put the negative sign or positive sign to show the direction as well. And divided by 10%, which is change in price. And this gives us minus 0.5. We also write elasticity in absolute terms. So this gives us 0.5 in absolute terms. Okay. Now I'm going to draw a diagram to show the classification of or categorization of elasticity, all kinds of elasticity. Okay. And one more remark, please keep in mind that elasticity of demand is always negative, because due to the increase in price, whenever the price increases, the demand falls, because the demand curve is downward sloping, right? So elasticity of demand is always negative. Okay, so let's say this is -1, this is 0, -2, -3. Unit elastic, this direction, this is inelastic, elastic. So if the absolute value of elasticity, here this sign is called eta, which is used to denote the elasticity. Some books may use some other symbol, so it doesn't matter. So if the absolute value of elasticity is less than 1, so this means for every 1% change in price, quantity demanded change by less than 1%. Okay, so if that's the case, then we say the demand is inelastic. Demand is inelastic. Okay, and if the absolute value of elasticity is greater than 1, so this means for every 1% change in price, quantity demanded change by more than 1%. Okay, so if that is the case, then we say the demand is elastic. And if absolute value of elasticity is equal to 1, then we say the demand is unitary elastic or unit elastic. Okay, so this diagram will help you to remember the different kinds of elasticity. Okay, now let's do one more example. Let's say the price of oil increases from 100 to 110 trillion. Okay, so these are numbers in trillion barrels, let's say, and over a period of several years, the quantity demanded falls by or falls from 100 trillions barrels to 95 trillion barrels. 95 trillion barrels. Then the question is, what is the price elasticity of demand for oil? Price elasticity of demand for oil. Okay, so we go by definition. So elasticity is the percentage change in quantity demanded divided by percentage change in price. Okay, so what is the percentage change in quantity demanded? Let's say from 95 to 100, okay, divided by 100. This is the percentage change in quantity, and for percentage change in price, we subtract 100 from 110 and divided by 100. Okay, so this gives us minus 5% divided by 10%, which is minus 0.5 or 0.5 in absolute terms. Okay, now here you can notice that I subtracted 100 from 95. Okay, because I know that the quantity demanded falls from 100 to 95. So I did the subtraction of 100 from 95. But I can also frame this question in a different way, that the price of oil increases from, let's say, 110 to 100, and quantity demanded, okay, so this is false. Price of oil falls from 110 to 100, and quantity demanded increases from 95 to 100 trillion barrels. Okay, and the question is same, price elasticity of demand for oil. So in this case, we can calculate percentage change in quantity demanded as 100 minus 110 divided by 110, and this gives us 5.26% divided by minus 9.09%, and this is 0.579. all right, or in absolute terms we can write 0.579. So here you can see that there is some difference in our answer. Okay, although there is the very minor difference, but when the quantities are larger, then the difference becomes very significant. Okay, so we can see that the fundamental formula is not that effective when it comes to points, when it comes to two different points. So these are basically points, right? These are two different points on the demand curve. So when there are 2 points on the demand curve, our fundamental definition does not give that accurate answer. There is some biases in the answer. Okay, so in order to omit that bias or the choice of base point, we use the different formula, which is midpoint formula. Okay, so midpoint formula. So this erases the natural biases associated with the choice of base point. Okay, so the formula is, for the numerator, percentage change in quantity, we write Q1 minus Q0, let's say, and we take the average of both the quantities, so that we do not have to worry about, which one is the first quantity, which one is the second quantity. Okay, so we take the average of both q0 plus q1 divided by 2, and then change it into percentage. Similarly, for percentage change in price, p1 minus p0 divided by p0 plus p1. Okay, we take the average and change it into percentage. So this is the midpoint formula. Now let's do an example. Let's say when the price is $10, quantity demanded is 100. When the price rises to $20, quantity demanded is 90. Okay, so let's calculate the percentage change in quantity demanded. So you can use the above formula. So this is 90 minus 100 divided by 100 plus 90 divided by 2 times 100%. So this gives us minus 0.5%. Now in the numerator, it doesn't matter whether you do the subtraction from whether you do the subtraction of 90 minus 100 or 100 minus 90, because whenever you switch in the numerator of percentage change in quantity, you have to do the similar switch in the percentage change in price as well, right? So this can eliminate the change. This can eliminate your positive or negative signs. Okay, so it doesn't matter which one you do first, but please make sure that you maintain the consistency, while doing the calculation of percentage change in quantity as well as percentage change in price. So percentage change in price is equals to 20 minus 10 divided by 10 plus 20 divided by 2 times 100. And this is 66.6%. Okay, so the elasticity is minus 10.5% and 66.6%, which is minus 0.15. Okay. Okay, so what can we say about the elasticity here? Since the absolute value is less than 1, we can say this is inelastic. All right. Now we have another formula for elasticity, which is point formula. And as the name suggests, this formula is used when there is 1 point on the demand curve. Okay, so the formula is price elasticity at point q naught p naught is equals to 1 over slope times p naught q naught. So it describes the elasticity of a small change around 1 point. Okay, so let's do an example. Let me draw the graph. This is price, this is quantity. Let's say this is 20 and this is 5. Let's take a point. This is the point A. This is 3 units. This is 8. So what is the elasticity at this point? So elasticity is given by P over Q times 1 over slope, right? what is P? P is 8, Q is 3. And what is slope? Slope is 20 over 5. And since the line is downward sloping, we put the negative sign. So this gives us minus 2 over 3. So this is very easy example. Now let's do one more example. Okay. So again, this is on the vertical axis for price. Here quantity. Let's take this point. Price is, let's say, 4. Quantity is also 4. Let's take one more point. Say price is 1. Quantity is 10. And this is 12. Okay. This is 6. And let's say the highest value is 12 again. Okay. Now let's find out the elasticity at these 2 points. Let's say this is A, this is B. So elasticity is given by P over Q times 1 over slope. P is 4 and Q is also 4. What is slope? Slope is minus 6 over 12. So this gives us minus 2. And at point B, P over Q is 1 over 4 and slope is basically same. So minus 6 over 12. And this gives us minus 1 over 5. So here you can notice that. And what can we say about the elasticity? So this is inelastic, right? And this is elastic. So you can notice that on the same curve, same demand curve, you see 2 different elasticity, right, when you move along the curve. So my question is, do you find any pattern? Can you find any pattern? Okay, so let's say, let me draw one more graph. Price, quantity, and this is the demand curve. Okay, let's say this is A, this is B, and this is right angle, right? Okay, so let's take the midpoint. Now my claim is elasticity at this point is -1, or the demand is unitary elastic. Unitary elastic. Now how do you prove this? So let's prove this. Let's connect a line from the right angle to the midpoint. Let's call this angle beta and this alpha. And we know this line segment and this line segment will be equal, because this is the right angle and this line segment connects the midpoint. Okay, so these 2 angle will be equal and this line segment is also equal. Okay, and let's call this point Q comma P. So since alpha equals to beta, we can write tan alpha equals to tan beta, right? Now what is tan alpha? So tan alpha is negative slope, because the line is downward sloping. What is tan beta? Tan beta, let me drop a line from the midpoint to the horizontal axis. So this is BP and this segment is Q, right? So tan beta is P over Q. Now let's bring the slope to the right side. So P over Q to the times 1 over slope is equals to -1. Now this quantity is point elasticity. Point elasticity, which is equals to -1. So you can see that elasticity is -1, okay, or the demand is unitary elastic. Now what about the points above the midpoint? So let's take a point here. Let's call it Q comma P again. Again, we'll do the similar geometry calculations. We'll draw a line from the right angle to this point, and now this time again we call it beta, and this angle is again alpha. Now at this time beta angle is greater than alpha, right? And so tan beta is greater than tan alpha because tangent is the increasing function, okay? And tan beta, what is tan beta? So when you draw a line segment to the horizontal axis, this is P and this whole thing is Q. So tan beta is P over Q and tan alpha is negative slope, right? Now let's bring the slope to the left side. P over Q times 1 over slope, and since the slope is negative we need to change the inequality sign, so this becomes less than -1, and this is point elasticity, right? So elasticity is less than -1. So the demand is or you can say the elasticity is less than -1 at all points above the midpoint, right? So this is -1, or we can say the demand is elastic because the absolute value is greater than 1. So demand is elastic. And with the similar geometric calculations, you can find out at any points below the midpoint demand is inelastic, or elasticity is greater than -1. Okay, so you can do the similar geometric calculations. You can join this point and this point. You can draw a line, again take the beta and alpha, and at this time alpha is greater than beta, so inequality reverses, and you'll get the demand inelastic at all points below the midpoint. Okay, so now one more question. As we go down the midpoint, as we go down along the same demand curve, from the midpoint, we can what can we say about the inelasticities? Because all these, we know that all these points below the midpoint are inelastic, but as we go down from the midpoint, the inelasticity increases, the points becomes more and or the demand becomes more and more inelastic. So as we go down, the demand at the points becomes more and more inelastic. Okay, all right, now let's talk about two extreme cases of elasticity. So first case is perfectly elastic. Perfectly elastic. So in this case, elasticity is infinity, or since we are talking about the elasticity of demand, we can say negative infinity. Okay, so let me draw the graph. P, Q, and we have a horizontal line parallel to the horizontal axis. So now let's use the point elasticity formula. So we have price elasticity equals to P over Q 1 over slope. We may take any point on this line, q comma p. Okay, but what is the slope of this line? So the slope is 0, right? Because this is parallel to the horizontal axis. So p over q times 1 over 0. Now what is 1 over 0? This is infinity, right? So we get elasticity is equals to negative infinity. Why negative? Because the elasticity of demand is always negative. Okay, so this is one extreme case. Now let's consider the another extreme case. Perfectly inelastic demand curve. Okay, let me draw the graph. So this time we have vertical line parallel to the vertical axis. This is P, this is Q. Let's take any point, Q comma P, and we have price elasticity equals to P over Q times 1 over slope. Now what is the slope at this time? So slope is infinity, right? Because the line is vertical, parallel to the vertical axis. So the slope is infinity. Now what is 1 over infinity? This is 0. So elasticity is 0. That's why we call it perfectly inelastic. Perfectly inelastic. Okay. So far we covered different types of elasticity or categorization of elasticities, and we also talked about different formulas of elasticity. How do we calculate them, right? Okay, so that's it for this video. Thank you so much for watching.